So good morning all. In this section we will see what is the input impedance of a transmission line, that is a lossy transmission line. Okay, now here I have drawn a transmission line and you can see this is the generator side. Okay, this is the generator side, or otherwise the source end, and here the generator or the source is having a voltage Vg and its impedance is Zg. Similarly, the load side is having an impedance ZL, and here you can see another term Zin, which is the input impedance. And here have taken two different points. This point is assumed as Z equal to 0 and this is Z equal to L. So Zin means the input impedance that you see at different distance. Suppose if you are seeing from this end, then I can say that it is the Zin that you see at Z equal to 0. Okay, so if I am marking like this, then I can say, and if I am marking like this Zin, then I can say this is the input impedance I see when I am standing at point Z equal to L. Okay, that is input impedance. Yeah, input impedance, it is the impedance we see when looking into the transmission line from different length. Now we know Vs equals V0 plus into exponential minus gamma Z plus V0 minus exponential plus gamma Z, which we derived earlier. The first term represents the incident wave along the plus Z axis, because here exponential is having a minus term, so the wave is along the plus Z axis, and the second term is of your reflected wave, which is moving along the minus Z axis, because here the exponential term is plus. Similarly, you have Is of Z equals I0 plus into exponential minus gamma Z plus I0 minus exponential plus gamma Z, which we derived earlier. Also we know Z0. What is Z0? That is your characteristic impedance. You have Z0 is equal to V plus by I plus. Also we have Z0 is equal to minus of V0 plus by I0 plus. This also you can go through the previous derivations under characteristic impedance of transmission line. Now next, this equation 1, 2, 3 and 4 is already derived. Now next what we are going to do is we are going to substitute 3 and 4 in equation 2. Okay, 3 and 4 in equation 2. So if I substitute 3 and 4 in equation 2, so how will I write? What is I0 plus? From equation 3 I can write it as I0 plus is equal to V0 plus by Z0. Similarly, I0 minus it can be substituted as V0 minus of V0 minus by Z0. Okay, so finally the equation 2 looks like this, that is Is of Z is equal to V plus by Z0 exponential minus gamma Z minus V0 minus Z0 exponential gamma Z. Next I am going to substitute the condition at Z equal to 0. So here you can see in this picture Z equal to 0 is near to the generator side and Z equal to L is near to the load side. Okay, so at Z equal to 0 I can substitute here. If I substitute Z equal to 0, I can substitute Z equal to 0 in which equation? In equation 1. Okay, so if I substitute Z equal to 0 in equation 1, then what happens? Vs of 0 is equal to V0 plus V0 minus. Right, V0 is equal to V0 plus V0 minus. Similarly, if the next what I am going to do is I am going to substitute z equal to 0 in equation 5. Equation 5. So I can write it as I of 0 is equal to v0 plus by z0 minus v0 minus by z0. So now this is how my equation 1 and equation 5 looks like. Okay. Now from this equation I can write I naught into z naught is equal to v naught plus minus v naught minus. That is my equation 7. Now using this 6 and 7 I will get v naught plus is equal to half v naught plus I naught z naught. Similarly, v naught minus is equal to half into v naught minus I naught z naught. This is my 8th equation and this is my 9th equation. Now I am just redrawing the equivalent circuit of the input side, that is the generator side. So now this is how the input side looks like. That is, there will be a voltage source, that is a generator whose voltage is Vg and whose impedance is Zg, and there will be an input impedance Zin, and the voltage across this input impedance is marked as V naught and the equivalent current is marked as I naught. So this is how the input side of the transmission line looks like. Now from this diagram you can find out the value of V naught. What is V naught? According to voltage division formula, V naught is equal to total voltage. What is total voltage? Vg into that resistance. What is that resistance here? It is an impedance Zin divided by the total impedance, that is Zin plus Zg. So that is my equation 10. Similarly, what is V naught in? Similarly, we know what is V naught. V naught is also equal to I naught into Zin. Okay, V naught is I naught into Zin. So both these equation 10 and equation 11 are equal. Okay, like this equation 10 gives you V naught in terms of Vg. Okay, and equation 11 gives V naught in terms of I and Z. That's all. So both the output here, this V naught will be equal to this V naught. So I can equate it. So finally I will get I naught Zin is equal to Vg Zin by Zin plus Zg. From that my I naught is equal to Vg by Zin plus Zg. That is my equation 12. So next we will go to the load side. That is, load side means here you can see corresponds to Z equal to L, because Z equal to L is near to the load side. So what happens? Instead of Ez, I am going to rewrite the expression as VL is equal to V naught plus into e raised to minus gamma L. Okay, in the initial equation, in the first equation, you have to substitute Z equal to L. So V0 plus into e raised to minus gamma L plus V naught into e raised to plus gamma L. Similarly, IL is equal to V naught by Z naught into e raised to minus gamma L minus V naught by minus by Z naught into e raised to gamma L. So these are those two equations. This one, and here in this equation you can substitute Z equal to L. Similarly, in this equation you can substitute Z equal to L. That is written here. Okay, so this is my equation 13 and 14, and using these two equations I can find out V0 plus and V0 minus, which is my equation 15 and 16. Okay, now from the generator side, from the generator side the input impedance will be P S of Z by I S of Z. Okay, which is equal to Vs of which is equal to Vs of 0 by Is of 0. This is the generator side. We are going back to the generator side. Okay, Z in is equal to Vs of Z by Is of Z, simply voltage by current. That is equal to Vs of 0 by Is of 0, because Z equal to 0 is near the generator side. Then what is Vs of 0 and Is of 0? Okay, so Vs of 0 is equal to what? V0 plus V0 minus, and Is of 0 is equal to V0 plus minus V0 minus by Z0, right? Here it is, you can see Vs of 0 is equal to V0 plus V0 minus, and Is of 0 is equal to V0 plus by Z0 minus V0 minus by Z0. This is the voltage and current at which side? At the generator side, that we are substituting here. Okay, here. Okay, so simply rearranging Z0 into V0 plus V0 minus by V0 plus minus V0 minus, that is my 17th equation. And then I am substituting 15 and 16 in 17, which is my 15, this one, 15 and 16, 15 and 16 in 17th equation, that is this one. So Zn is equal to Z0 into VL plus IL, Z0 e raised to gamma L plus VL minus IL, Z0 e raised to gamma L, the whole divided by VL plus IL, Z0 e raised to gamma L minus VL minus IL, Z0 e raised to minus gamma L. So finally you will get there is your, from this numerator you will be taking VL as a constant, so you will get VL as not as a constant, as a common term, VL into, simply I am rearranging e raised to gamma L plus e raised to minus gamma L plus IL Z0 into e raised to gamma L minus e raised to minus gamma L. Similarly you will be doing with the denominator also. The next step, what we are going to do is I am going to substitute this identity, that is, we have already studied sin h of theta, cos h of theta. So here sin h gamma L is equal to e raised to gamma L minus e raised to minus gamma L by 2, and similarly cos h gamma L is equal to e raised to gamma L plus e raised to minus gamma L by 2. That you will be substituting in this equation. This one will be substituted here, and now the equation looks like this. The next step, what I am going to do is divide the numerator and denominator by IL cos h gamma L. Okay, IL cos h gamma L. So finally it will look like this. Zn is equal to Z0 into VL by IL plus Z0 tan h gamma L divided by VL ZL tan h gamma L plus Z0. And what is VL by IL? VL by IL is your ZL, which is your load impedance. So that is substituted here. So final expression is Zin is equal to Z0 into ZL plus Z0 tan h gamma L by ZL tan h gamma L plus Z0. And this is your expression for input impedance. And here you can see a special case, that is for in the that of a lossless medium. In the case of lossless medium, Zin is equal to Z0 into ZL plus J Z0 tan beta L by Z0 plus J ZL tan beta L. And this is the expression for lossless medium. It's a special case of lossy medium. That is, you have to substitute alpha equal to 0. Alpha, that means you know what is gamma. Gamma is equal to alpha plus j beta. Here you can substitute alpha is equal to 0, and that condition can be substituted here. In place of gamma, finally you will get what Zn for lossless medium. And that's all in this video. Thank you.